Students, good afternoon. Now I want to discuss Cannizaro reaction. Aldehydes having without alpha hydrogen involved in nucleophilic addition reaction in the presence of concentrated base and form alcohol and carboxylate anion. So alcohol and carboxylate anions are formed. This reaction is known as the disproportionation redox reaction. Why it is called disproportionation redox reaction? Among the two alpha without alpha hydrogen containing aldehydes, one aldehyde oxidized, another aldehyde reduced. That's why it is disproportionation redox reaction. In which mechanism hydride ion transfer step is slow step. That's why it is RDS, rate determining step. So these are the key points. So hydride ion is slow step. It is a disproportionation redox reaction. So alpha hydrogen without alpha hydrogen containing aldehydes involved. Without alpha hydrogen containing aldehydes involved. Aldehydes having without alpha hydrogen. Without alpha hydrogen. Formaldehyde is best example. Formaldehyde. You know, it is functional group. Functional group adjacent carbon is alpha carbon. There is no alpha carbon. That's why there is no alpha hydrogen. So formaldehyde involved in Cannizaro reaction. Next example. Benzaldehyde. Benzaldehyde. Functional group. It is functional group. Functional group adjacent carbon is alpha. Is it alpha? No. Because it is sp2 carbon. Always functional group adjacent carbon, if it is sp3 carbon, that is called alpha carbon. In a molecule there is no sp3 carbon, means there is no alpha carbon. So functional group adjacent carbon, if it is sp3 carbon, that is alpha. So here no sp3 carbon, no alpha carbon. Clear? So benzaldehyde, no alpha carbon. Trichloroestaldehyde. This is functional group. Adjacent carbon, alpha carbon, sp3 carbon. Alpha carbon is there, but there are no alpha hydrogens. So it is involved in Cannizaro reaction. Trichloroacetaldehyde. Trichloroacetaldehyde. Chloral, another name, chloral. Now, another example. CH3, 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 C double bond OH. It is functional group. Adjacent carbon alpha, sp3 carbon. So it is also involved in Cannizaro reaction. What is the name? 1, 2, 3. 2, 2. Dimethyl, 2, 2 dimethyl propanol. 2, 2 dimethyl propanol. So these are all involved in Cannizaro reaction because they don't have alpha hydrogen. Now reaction. 2 moles formaldehyde. Presence of concentrated base. Concentrated base. One aldehyde reduced. Another aldehyde oxidized. One aldehyde reduced, another aldehyde oxidized. methyl alcohol, sodium formate, sodium formate. This is reduction, reduced form. This is oxidized, oxidation form. Clear? One aldehyde oxidized, one aldehyde reduced. That's why it is called disproportionation redox reaction. Disproportionation redox reaction. Now, its mechanism. You can take formaldehyde. So double bonded carbon sp2 carbon. It is a trigonal planar shape. sp2 hybridization, bond angle 120 degree. Now OH minus, pi bonded electrons migrating towards oxygen. On oxygen negative charge existed, at carbon positive charge existed. Positively charged carbon is electrophilic nature, where nucleophilic nature of hydroxide ion can attack. Then one unstable tetrahedron intermediate formed. This is. Now second mole you can take. Second formaldehyde plus first unstable tetrahedron intermediate. Now non-bonded electrons involved in pi bond formation. Now hydrogen moving along with its bond pair electrons, that one can attack adjacent electrophilic nature of carbon. So here hydride ion transfer from one molecule to other molecule, so that's why it is hydride ion transfer step. Hydride ion transfer step. It is a slow step. You know, slow step is called rate determining step. Slow step is called rate determining step. Understood? Because pi bond making, sigma bond breaking, again sigma bond making, pi bond breaking. So that's why slowly proceeded. So it is slow step. That's why it is called rate determining step. HCH single bond O minus, here hydride ion shifted to here, plus HC double bond O, HC double bond O, OH. Clear? So now here OH bond is more polar bond. So that formic acid readily give H plus. Why? The formed formate ion is resonance stabilized. That hydrogen shifted to here. Then CH3OH methyl alcohol plus HC double bond O minus, anion followed by cation. Clear? This is H plus transfer step. Okay, H plus transfer step. So clear? This is the mechanism. So very important mechanism. It is very important mechanism. Clear, everyone? Yeah. Example. Benzaldehyde. How many carbons are there? 7 carbons are there. Concentrated NaOH. Okay, 7 carbons are there. Benzaldehyde. It does not have alpha carbon alpha hydrogen also. So it is participated in Cannizaro reaction. Now one benzaldehyde molecule reduced, one benzaldehyde molecule oxidized. Clear? One benzaldehyde molecule reduced and one benzaldehyde molecule oxidized. Understood? So one benzaldehyde molecule reduced, one benzaldehyde molecule oxidized. So that's why it is a disproportionation redox reaction. So very simple, 7 carbon containing aldehyde reduced to 7 carbon containing alcohol, 7 carbon containing carboxylate anion. So just you can count the carbons. Why? Sometimes instead of this benzyl alcohol, its name benzyl alcohol. It is not phenol, benzyl alcohol. Sometimes generally instead of benzyl alcohol, phenol given. In options, phenol provided. That's why just you can count the carbons here. 7 carbons na. 7 carbon containing alcohol, 7 carbon containing carboxylate anion. Okay. Sometimes benzaldehyde concentrated base given. Yes, 4 options. In one of the options, phenol plus sodium benzoate given. But which is the correct option? Benzyl alcohol and sodium benzoate, not phenol plus sodium benzoate. Clear? So very important. Now moving to next page. Crossed Cannizaro reaction. Crossed Cannizaro reaction. Above one is self Cannizaro reaction. Now crossed Cannizaro reaction. So crossed Cannizaro reaction means two different aldehydes participated. Two different aldehydes having without alpha hydrogen. So two different aldehydes having without alpha hydrogen participated. Suppose two different aldehydes, one aldehyde without alpha hydrogen, another one having alpha hydrogen. That is crossed aldol condensation. Here two different aldehydes, both do not have alpha hydrogens. So they are involved in crossed Cannizaro reaction. Now, so here one important doubt: which aldehyde reduced, which aldehyde oxidized? That is very important. Which aldehyde reduced, which aldehyde oxidized? So very important. Simple aldehyde. Simple aldehyde oxidized to. Simple aldehyde oxidized to carboxylate anion. Bulky aldehyde reduced to alcohol. Okay, bulky aldehyde reduced to alcohol. Very important. Simple aldehyde oxidized to carboxylate anion. Always bulky aldehyde reduced to alcohol. Okay, here mechanism no need. Okay, simple aldehyde. Suppose formaldehyde and benzaldehyde. Formaldehyde, benzaldehyde. So concentrated base. So formaldehyde, benzaldehyde. Which is simple aldehyde? You know, comparatively, this is simple aldehyde. Okay, which is bulky? This is bulky. Comparatively. Okay, comparatively. Which is simple? formaldehyde, which is bulky benzaldehyde. Now, simple aldehyde oxidized, one carbon containing carboxylate anion means sodium formate. Okay, and so simple aldehyde oxidized. Now, bulky aldehyde reduced. So, bulky aldehyde reduced into alcohol. Okay, benzyl alcohol. So, benzyl alcohol, bulky aldehyde reduced into benzyl alcohol reduction form. Clear? So, simple aldehyde oxidized, bulky aldehyde reduced. So, any you can write, any one. Second example, formaldehyde. Okay, formaldehyde. So, this is bulky aldehyde. Bulky aldehyde. Because alpha carbon is there, but there is no alpha hydrogen. Formaldehyde, no alpha carbon, no alpha hydrogen. So simple aldehyde oxidized, bulky aldehyde reduced. Sodium formate plus CH3 thrice C, it reduced to CH2OH. Clear? Oxidized. Okay, reduced. Understood? Oxidized, reduced. Understood? This is a crossed Cannizaro reaction. I hope everyone understood this one. Now, intramolecular Cannizaro reaction. Intramolecular Cannizaro reaction. Intramolecular Cannizaro reaction means within the same molecule Cannizaro reaction done. Within the same molecule. Within the same molecule. Within the same molecule. Cannizaro reaction. Cannizaro reaction takes place within the same molecule. In our syllabus, there are two examples. There are two examples. What is the name? Glyoxal. What is this? Glyoxal. Concentrated base. So glyoxal. So in this molecule, any sp3 carbon is there, alpha carbon is there? No sp3 carbon. Both carbons are double bonded carbons, means sp2 carbons. So definitely with respect to this aldehyde, this is sp2 carbon. With respect to this aldehyde, above carbon is sp2 carbon. There is no sp3 carbon. There is no alpha carbon. That's why, yes, it is involved in intramolecular Cannizaro reaction, because the two aldehyde groups present in one molecule, one aldehyde reduced, another aldehyde oxidized. So now, above aldehyde oxidized, for example, below aldehyde reduced, oxidized reduced. This is product. Now, example 2. Example 2. Its name thalaldehyde. Its name thalaldehyde. phthalic acid, so it is phthalaldehyde. Okay, phthalaldehyde. Now here, one aldehyde, okay, phthalaldehyde, one aldehyde oxidized, another aldehyde reduced. Clear? One aldehyde oxidized, another aldehyde reduced. So I hope everyone understood this concept, Cannizaro reaction concept. So very important concept. Okay, we have learned here self Cannizaro reaction, crossed Cannizaro reaction, intramolecular Cannizaro reaction. Clear? In phthalaldehyde, actually, no, there are no sp3 carbons, all are sp2 carbons. That's why one aldehyde oxidized, another aldehyde reduced. So clear, everyone? So very important concept. Please go through this lecture and please observe a number of times. Definitely will get clarity, 100% clarity. You can solve any relevant question. Thank you so much.